there is a lot going on in that car in that 6-second period. And during that 6-second period, going back to the methanol, we're burning 6 to 7 gallons of methanol on one run. So for us, elapsed times are quite often really made in the first 60 feet, the first 100 feet. So when they talk about 0 to 60 in 4 seconds, we're 0 to 60 in like 0.9 seconds, you know. So without trying to make it too confusing for your audience, we're handicapping the race, and you're doing that to make it equal. So that way money is not the major factor.
Hey Keith.
Hey, how are you?
Nice to meet you.
Nice to meet you too, sir.
So Keith, can you explain about your car?
So our 2012 McElvain dragster we purchased in 2013. We converted it to a blown alcohol deal in 2016, and we did that to accommodate NHRA's top dragster series, which is very, very competitive at very quick speeds. It is a bracket handicap style racing class.
Okay.
This car here in particular is a McElvain built car, as I said. We have a fairly small tire with a billet rim. The rims are certified, stamped, SFI inspected by NHRA, and are made to a certain spec to ensure safety. Beyond that, as we move back, and this particular car, we have our fuel cell, which is located right here. We do our filling for the fuel cell. At this point, it holds 7 gallons of methanol, which is the fuel we burn in this car. Oddly enough, if you look in, you might see the steering for the shaft actually runs right through the center of the tank. So there's quite a bit of fabrication in there to make all of this work. As we start to come back to the car, this area here is basically got some electronics underneath that were not got exposed. But as we move into this compartment, we do have regular relays for power, but I also have in here a computer race pack data recording system. Now, we are not allowed to make certain changes to the car during the run with that system, but I am allowed to record all the information that the motor and transmission and car use, so that enables me to make adjustments for the next run. Once we get up to this area is a driver's compartment. This area is a fairly strict area. As you can see, NHRA tags this area. They sonic test all the bars. They're made sure they're a certain thickness, and that all the welds are intact. The driver is checked to be safe, and then gets certified by NHRA. It carries a 3-year term, and then we have to renew it. In the driver's compartment, we have levers for brakes, parachutes, starting systems, fuel shutoffs. It's kind of a common thought that in drag racing, you're just stepping on the gas and going.
Yeah.
But there is a lot going on in that car in that 6-second period. And during that 6-second period, going back to the methanol, we're burning 6 to 7 gallons of methanol on one run. So we're putting a lot of fuel through this system. We put fuel through a mechanical pump, and if you can see, we have a fairly large line, a 1-inch line bringing fuel in, which feeds up into our injector. The injector distributes the fuel through different areas of the upper hat and the intake manifold into our deal, and the blower is pushing the fuel and air system into the motor, giving us a little more power. Obviously, it's a power adder. We have belt guards, and again, certified belts that normally are strapped down to here, and they keep the blower on in case of explosions, so there's no injury to fans or the drivers. Exhaust pipes on this car, we call them zoomies. These pipes are 2.5 inches in diameter and very, very critical to the car's horsepower.
What's the material? What's it made of? What, like
this is a stainless steel, and they're made by McElvain, so the chassis builder hand fabricated those headers for our combination. Our particular combination is called a B1. It's based off the Chrysler Wedge.
Okay.
It is a Chrysler-based product that Dave Kolfel in Huron, Ohio, formerly a Chrysler race engineer. Dave developed the cylinder head for the Pro Stock program in NHRA back in 1985-86 era. We have been in contact with Dave for probably 20 years doing business, and we use their product very proudly. Great product, and we're happy with it. Again, with the amount of fuel we use, we have to make sure we can burn it all. We use an MSD 44 amp magneto, and we also use NGK spark plugs to make sure we can ignite all that fuel. Very important to use the fuel and burn it correctly, or you're not going to make the lap times we want to.
What does that magneto does? Like you said, like before spark plug, there is one device that.
So the magneto is actually spinning and creating spark. On a normal car, you might make 6-7 amps. To understand this, in the early days, and I'm going back before my time, but my parents' house, they would run a whole house on 60 amps of power. Yeah. We're running this motor on 44 amps. Wow. That's a lot of amperage to burn fuel. Yeah. You know, yeah. But it's critical to do that, because without that, you cannot burn fuel, and if you can't burn fuel in air, you can't make power. Yeah. You know, so to try and move this car moves 4.1 Gs at a quarter second into the run. You're trying to move 2,000 pounds of weight in a very, very small time. So for us, elapsed times are quite often really made in the first 60 feet, the first 100 feet. Okay. In the first 100 feet, this car is probably close to 100 mile an hour. So when they talk about 0 to 60 in 4 seconds, we're 0 to 60 in like 0.9 seconds, you know. That's the idea. Okay, so again, there's multiple safety requirements. On the back of the intake manifold, you'll notice there's a square pouch here that's got a blow-off plate. In the event, quite often we see in the nitro classes, you'll see big explosions. What they're trying to do is alleviate pressure from the motor. If we backfire or drops a valve or something goes wrong on the intake side, it will release pressure through that before it tries to take the blower off. If it does take a blower off, the studs are made of aluminum, they're made to shear, it's mandated by NHRA, and once that happens, these straps, as I said, take over and maintain and keep that intact. When things like that happen and you start to put all that boost and pressure into a motor and you have to relieve it, quite often, in a case like last night, we lost a valve and a piston. It went through number 7 cylinder and it filled up this tank, and people will ask, what is the tank for? The tank is, again, a safety device that is used to collect all the oil, fuel, and pressures from the motor when it gets over boosted. So last night we put about 12 liters of oil into that tank. If that does flow over, sometimes fills them out, the filter's up here, because it's got to breathe. We choose to mount ours down on the bottom at the wheelie bar. Dean McElvain designed that idea. We feel it's a safe idea. It's behind the tire. If you have that catastrophic of a problem, we are going to oil the track down. We can't stop it at that point. But we're not going to want to crash a car, obviously, so we want to keep the oil off those tires, you know. So those are some of the safety things. I mean, we use a Marco Abruzzi transmission. We've used transmissions from great suppliers like Joe Bondaferro at Bondaferro Speed and Custom. In this case right now, we're using a Marco transmission because he's done some work with our engine builder, so we're trying to keep the combination the same. The case is a bulletproof case. We've got billet yokes. You've got special bars and containment pans that are under the car, not necessarily easy to see, but they contain fluids or parts if problems arise. Okay. You know, normally we don't have problems.
So how many gears do you have?
In this car we have a 2-speed, a high and a low gear. Okay. We do have reverse. We activate our transmission to an electronic clutch basic system. So we're locking out a low gear, and when we release the button, the car releases. Yeah. Speaking of releasing the button, again, most people who've watched fantastic programs like Street Outlaws or NHRA, when they show their programs, they'll show the fuel cars and you'll basically see a guy just letting go of a brake or leaving. In our class, it's not just that simple. Our class is a handicap bracket racing class. So our thing is, we're the fastest bracket racing class on the planet. Meaning we can't go faster than 610 by NHRA rules, or 6 seconds is actually the mandatory speed. We can't dial less than 610. And what a dial is I have to indicate before the race how fast my car is going to go. I am not allowed to go under that number, but I still have to cross the finish line first. So literally at 221 miles an hour, I'm looking at my competitor to see and try and judge if I have a tire on or if I don't. The number you see here is what we indicate to the tower that they put on the scoreboard, our dial. So a handicap is set up where if you had a 6-second car and I had a 7-second car, it would be a 1-second head start. Theoretically, if we both left on a green light dead on zero and we both ran our indicated numbers, we would cross the finish line. NHRA has put this deal together, which is a tough class for the fans sometimes to watch or understand, but it is very competitive and makes it very equal for all the players involved. In this class, it doesn't matter who you are or what you are, everybody is trying to just win the race.
So it's just not about racing, it's about the driver also, right?
A lot of this class relies heavily on the driver and the starting area. Now, that being said, don't mistake what I say, because I'm very, in my case, some of the guys maybe not so much, but in my case, we've really pushed hard to make the car run the number that we want. We work very hard on tune-up. And I feel, personally, that if I can run what I believe the car will run, it makes it very difficult for my competitor to win. So, without trying to make it too confusing for your audience, we're handicapping the race, and you're doing that to make it equal. So that way, money is not the major factor. It is a factor, and there are multiple bracket classes. So our class, you have to run a minimum of 750 and can run no faster than 610. That's the area we're allowed to race in. Okay, they make classes slower for that, for other people that are in a different situation. On the back of the car, you'll notice we have a couple of parachutes. Mandatory in top dragster, 2 parachutes on any car with 200 mile an hour. Wings are mandatory. Now my wing is a little bit lighter and a little different than most. Most of our competitors don't use this style wing. It does not give a lot of downforce. This wing's job works exactly opposite to an airplane in that it's made to push the back of the car down. In top fuel, some of those wings can create as much as 8,000 pounds of downforce on a car. Literally, you'd be like putting 7,000 pounds on the car and pushing it to the track. That puts a lot of force into it. This wing here is nowhere near that, and probably puts a few hundred pounds of downforce depending on our angle. We can adjust slightly the angle on it, but for this car and the McElvain chassis, it works very well. Very happy with it. The car is very stable at the top end. It's like driving a car down the highway, it really is. We also run a wheelie bar. As I said earlier, you can see the vents. The wheelie bar is used for a couple of different situations. It's used to stop the car from levering over, which is the obvious situation, but also in recent years, a lot of classes have started to use it to control wheel speed. So they'll hit the wheelie bar purposely harder or softer to make the tire move or grow. And the tires on a car like this are very critical for air pressure. We're running, in our case, about 6.5 pounds. We don't miss them by 1/8 of a pound. They are exactly equal, very closely monitored and very important, you know. All cars in NHRA drag racing have a small light. Anybody ever wondered, you'll see as we turn on power, the light comes on. The reason for that light is in the event of a bad accident, they want to try to be able to see where the light went to at night. It's a mandatory thing. Kind of makes simple sense, really, you know. Our cars in NHRA and IHRA, but we're an NHRA track here. We have a number and a class, so top dragster, and 2128 is our national number, okay? Again, the rear rims are billet, slightly different than the front, in that the construction and the idea is the same, but obviously they're wider. Also, they're what they call a bead lock. So we put the tire rubber bead that you see when you buy a normal pair of car tires, and we lay that on the outside of the rim, and we pinch it with this ring, and it's done the very same on the inside. Very safe way to keep the tire from moving or getting distorted or causing a problem coming off the rim. It keeps everything tight where they belong, you know. Our car in the back is a 4-link car, meaning it's suspension. So I think earlier in one of the conversations we discussed Is it solid like the fuel cars, or is it suspended? Our car is actually suspended. You can see we have suspension in it. I have a single mono shock, and it's a lower swing arm with 2 upper bars. It's a Dean McElvain design that I think a lot of people are skeptical on, but anybody who's had Dean's products knows that he's a man who's building incredible products and has a really great attention to detail. I mean, when you buy a car from Dean, the bolts all face the same way. He's that kind of guy, you know. You can see from this side. On this side, we still have the blower restraints, as I was showing you earlier. There's the pins they're in. Starting this car, that's something that we haven't talked about, and you know, you think you just turn a key or something. Well, in our case, we have crew members, and I'm pretty particular about who's around the front of the motor, and I'm like that for safety. These blower belts are pretty tough, and it's not the kind of thing you want to get your fingers caught in. In our case, my wife Wanda, who's raced with me all my life, takes care of the starting procedures, and how she does that is we'll have a can of fuel, which is actually located in the trailer at the moment, but we'll use this as an example. We'd have a can of fuel. She would open up the hat. She'll squeeze some fuel into the injector hat. Once she's done that, she'll put a clip on the burnout, on the lever here for my burnout, because we do not want to go wide open throttle on the burnout. When we do a burnout, we're only cracking the throttle a very, very small amount. And we want to keep the RPM in a range that we feel is going to work for keeping our motors safe and put good heat in the tire. Once she's done that, she puts her clip on, she'll tell me in the car if she's ready. I will push the start, which is our crank, and I'll hit the magneto button. At that point, because the motor is run dry, she will still continue to squeeze fuel into the hat, and you'll hear the RPM come up, and then you'll hear it settle. When it starts to settle, she knows the fuel is coming through the pump, now going through the injector and injecting into the motor. We inject fuel in this motor up at the top through the injector hat. We also inject fuel to the bottom at the intake manifold. So on a normal car engine, you might have one of these nozzles in a car to inject on an old carbureted car, maybe 2. We're using 16 here. And on fuel cars, they could be using 30.
So it's a V8, so each cylinder has 2 injectors going.
It has, each cylinder has 1 at the moment, plus we have some at the blower which feed the whole motor to try and balance things out. So you gotta remember, in the blower, it's not centered on the motor, so it acts differently at the front versus the back of the motor. Okay, so typically on a run, on our particular combination, our cylinders might go a little leaner at the top, so it's not uncommon that we feed a little more fuel into those areas. Okay, so we're gonna go ahead and get in the car and show your viewers some of the things in the driver's area, and maybe just kind of go through what happens during a run. Quite often people think you just step on the gas, but it's really not that simple. So in any case, we'll climb in. I'll get my crew guy Derek, he'll pull some power on back there. As you can see, the car's kind of tight to get into. There is a knack. You kind of fall back, and you know, for me this is like home. I really like to be in here. So looking forward here, we have a cluster ahead of me. The cluster shows me engine RPM, voltage on our batteries. Oil pressure is one of the ones I really like to watch for. If I spot a problem there, I can shut the car off early and not cause a lot of damage, or oil down the track and cause problems there. As we look to the left, in our case, as I mentioned, it's a handicap race, so we would enter our dial and the opposing man's dial into my box so that we can calculate how and who's going to leave first. On the startup side, we have some crank buttons right here, and ignition mag button here. Up to the left is the fuel button, some brake handles, and our shifter. So on a normal run, what would happen is I would open the throttle blades, they would squeeze fuel into the injector hat. Once the car is cranked and lit, I would bring the shifter down to high gear and back up the crew member would tell me to move ahead, and we would start to move ahead and go through a burnout procedure. We drive through a little bit of water, and that takes a little bit of, makes it a little easier for the tire to spin. And the spinning and the tire burnout is done so that we can get a little heat in the tire and put some fresh rubber down on the track. And you'll notice quite often in dragster racing, they're backing the cars up, and it looks like they're giving them directions, and they are. There's usually somebody behind the car telling the person out front of the car to tell me left or right to put the car back into the same position in that rubber. Once we back up, I put the car into neutral. I put my hands and arms up. Obviously, all our belts are strapped in. I wear arm restraints. We wear carbon fiber helmets. We wear multiple layer fire suits for safety, all mandated by NHRA, and thank God they do. It keeps us safe. And they normally have a great safety safari, speaking of that, out there in case something does happen to help us if an event, there is an event on the track. Any case, once we do that, my crew person will come and she'll turn this button here, a little black button, and that is a reset on my computer. That's my data recorder. And that for us is really, really important. It's going to record everything we do from here until I shut the car off. Once we set that button, I will then move the car, roll it forward, and we roll into the starting lights. And I'll be holding this brake and the brake here with my left hand, and on my right hand, I'll be touching the red button, which will engage a trans brake and some air behind me. And when I release that, the throttle snaps open. The car launches, it'll shift to high gear, and as it shifts to high gear, we're already halfway down the track. We're about 3 seconds into our run at 600 feet, and then by the time we reach 1,300 feet, which is the end of our run, 6 seconds later, we're going to neutral. We're reaching over to the left, pushing parachutes, shutting off fuel, grabbing handbrake, and holding the steering wheel all at one time and trying to slow this thing down. At 200 miles an hour, and in this case 221 miles an hour we've gone, you're covering a lot of ground in a big hurry. So every second to get the car slowed down is critical. The quicker you can get that car down in speed, the safer the run is going to be. Once we get around the corner, at that point I'll release my belts, unhook my Hans device and my helmet. We'll start to take some gear off. We come back and we start the whole procedure of tuning, setting, recording, fixing all over again. And we do that in about a 45-minute turnaround time and go right back out and race again. So that's a quick overview inside for your viewers that think that someone just gets in, holds the steering wheel and steps on some gas. It's something like that, but there's a little more to it. All right, so also, speaking of the safety aspect, thank God over the years NHRA and different racers have researched and found fantastic products for us to keep us safe in these cars. I mean, it is dangerous, there are risks. It's not like we don't think about it, but I don't think about getting hurt in the sense that I have good people and good products. So there are a lot of good products out there. Simpson is one of the names we've used, and in this case right now we're using Impact products. There are many other products that are made, off the top of my head, I can't think of their names, but we use an Impact fire suit. This fire suit, in the event of a fire, is supposed to keep me from being burnt for a certain period of time under certain heat conditions. So we use a 15 or 20 layer suit. We're going to go ahead and put it on, and then we're going to climb in the car and show you that there's stuff going on. Just for your viewers' sake, this suit looks like it's fairly light, but it's actually about 42 pounds. So it's fairly heavy in kilos, probably 20 kilos. So there's some fire pants, and they're SFI certified, they're dated, it's watched and looked at. You'll see that that's dated, and NHRA checks those products. We also use a Simpson as the helmet I like to use in this case. We use the carbon fiber version of the Bandit. We like it, and that carbon fiber helmet is lighter than some, and it's to help keep our head safe, again, in the case of an accident. We hope we don't have one, but in the event that we do, we're going to be relatively safe. We also, under the helmet, put on a balaclava, and this is to keep fire from coming up into the helmet and burning your skin if something was to go on. I think we'll put it on and give you an idea that when you put all this stuff on and start to climb into a car, we then add a Hans device. This device saves you from breaking your neck. So I'll get my crew guy to put that on my head. Okay, so you can see that device is strapped and your head cannot move forward. That's to stop you from breaking your neck. And then you got to climb in the car from the wrong side with all that gear on. Squeeze in, and we start to put on gloves, which we wear, again, for safety. Impact racing gloves. Belts over the shoulders. Big belts. Both sides. That holds the Hans device tight to your body. So we're in the car, ready to go. So I want to take a minute and thank you guys for coming to my trailer and our racetrack. Toronto Motorsports Park is a fantastic facility for all people, all ages, all kinds of cars. Come and enjoy it. They got road course, drag racing. I want to say thank you, and I'm going to take a minute. This is one of the pistons we hurt in one of our last events. This piston has gone though, 609 at 221, and I'm going to donate this to my new friends. Thank you very much. Appreciate it. To meet you, sir. Honor's all mine. Thank you. Maybe I can sign a picture for you if you want. Sure. I'd be happy to do it. Alrighty. There you go. Thank you, sir. Appreciate you, fellas. Thanks, and we hope to see you all at the racetrack. See you soon.